Go. All right. At 5, this is 714. At 6, can you guys just not talk? You need to pay attention. I'm doing this work. Yes, but there are 2 people. Only 2 people did this. 3, and they got different answers. Did either of you? Who's the 3rd person? Did you get either of these answers?
No, I got in between.
Okay, so you got somewhere in
1,130.
somewhere in between there. 7.
Because that's your answer.
Okay, is that it? 7. Oh no, and then no, it should be.
No.
Oh yeah, then 8.
I got it wrong.
Wait, are these left or right?
Did you do number 4,
You
Mr.?
said left.
Yeah.
You did. You did
1.
right on 4.
I got it wrong.
300.
You did 5. It's
1,
4.
2, 3, 4, 5,
You messed
6,
up on the last
7, 8.
'Cause that's right
You messed up
point.
on the 4.
What's 4?
Yeah.
115.
115.
So one of these is
Yeah, I did it wrong, mister. I forgot to add 300.
It's 115, then 85, then
135,
65, then 50.
yeah, because this would go right in between here. All right, so you add those up.
It's 1258.
100. No. 300.
Right? That's what you got? Yeah, Maria's right.
Well, 1, 2, 6, 2.
You forgot to do the 8. Did you do the 8?
You should not do the 8.
No, because it's not. It's only the left side. It's not the right side. It's only the left side of the rectangle.
It's 11,000. I mean, no. 1,104.17.
Are we supposed to count the decimals?
It's like 1 something. 1,267.
So this was pretty close. Was this yours? So I mean, it was very close because you didn't keep track of the decimals. So 1267.07. Okay, so Alex, is that what you got?
What?
Something.
For my rounding one, I had gotten 1,260.
1,260.
Yeah.
Okay, which is pretty good. That's probably means you did it right. 260. So here's the thing. Even if I use this that I was pretty accurate with, 1267.07, you need to keep in mind that should I, or is it correct if I write equals that?
No, approximately.
Why is it only approximate?
Because we're over and
You were estimating.
Because this represents the exact area under the curve. Okay? This would be an approximation. How would I find the exact at this point in your life?
Calculate.
Using the calculator by doing second trace 7, this guy, from 0 to 8. So the exact answer, or at least close enough, much closer than what we did, was this. Okay? So here's the thing. You get this number. It's an approximation. This is the approximation, which is approximation of this. What does this mean in the context of this situation? Because I don't even have units on this, even though this problem definitely has units. So what are the units here? So let's first label the graph, because I don't know what the number means yet. So what are the units on our graph? This is R of t, this is t. So the t is easier. What are the units of t? Yes, I know time, but what are the units of time? Seconds? Minutes. I don't know what just happened there. Minutes. So the t value is in minutes. What is R of t? It's not gallons.
What?
It's gallons per minute. It says up here, represents the amount flowing out of the water measured in gallons per minute. So this is a rate, and this is time. So let's look at this. Each one of the rectangles, I'm just going to draw a generic rectangle. I have dt down here, and I have r of t as the height for each one. What are the units of r of t again? So here, let me change color. Let's do it again. Okay, r of t, gallons per minute, and t, come on. It's malfunctioning. I wasn't freaking out or something. Because I have to push down on the pen for it to make a mark. But sometimes it just didn't, like I lifted the pen up, but it was still moving around and making ink. So I wasn't just being ridiculous. Oh boy.
Control Z.
Okay. Let me go down here. Okay, so each rectangle, the units of each rectangle are gallons per minute, and then this is minutes on the bottom. So if I'm trying to find the area of each rectangle, and I'm multiplying base times height, the units of base are minutes, and the units of height are gallons over minutes. What happens when I multiply? So you're left with gallons. So when you find the area under the curve, you multiply the units, and whatever the units are, that's the unit of your answer of the area under the curve. So what the number we found was gallons, because we multiplied. Or the other way to think of it, when we did the r of t dt, r of t is gallons per minute, dt is minutes, and those cancel out when you multiply, because this is multiplication here. So this answer is in gallons. So what do you think that means in this context? What's happening in this problem? Water is leaking from a pool. So, from 0 to 8 minutes, what did we just find? What did we just find? The amount of water that leaked out. Okay? Because what's happening is, at the very beginning, 300 gallons per water was leaking. Then the leak subsided. There was less water at the end leaking. It was only like 50 or 40 gallons that were leaking. But all of that area under the curve represents the water that had leaked out. Okay, it's take the gallons per minute, multiply by the time, multiply them together, and that gives you the units of your area under the curve. So that's what this means in the context, is that you've lost this much water since it's leaking. Any questions? Okay, so to move on,